Very good morning. Today we are going to see a small problem on equivalent circuit of the transformer. Take down this problem. A 5 kVA, 2 winding, 220 bar, 110 volts step down transformer has a turns ratio of 0.5. That means N2 by N1, that is K, is equal to 0.5. And the primary winding resistance and reactance are 2.5 ohms and 6 ohms, whereas the secondary winding resistance and reactance are 0.25 ohms and 1 ohms respectively. Construct the equivalent circuit of the transformer referred to as secondary. So first, the transformer rating is 5 kVA transformer. Primary voltage is 220 volts. Secondary voltage is 110 volts. The turns ratio K is equal to N2 by N1 is equal to 0.5. The primary winding resistance R1 is 2.5 ohms, and the primary winding reactance X1 is equal to 6 ohms. Next, whereas the secondary winding resistance R2 is 0.25 and secondary winding reactance is X2 is 1. Now we need to construct the equivalent circuit of the transformer referred to as secondary. Now, approximate representation of the transformer windings, that is transformer connections, with respect to all these values. So, first is this is a core, iron core. So, in this N1 windings are there, N2 windings are there. So, the transformer is given as step down transformer. So as I said before, so if it is step down transformer, this primary windings has more and secondary winding has less. So if you are drawing 1, 2, 3, 4, 5, 6 windings here, so here should be 3 windings. It depends on that. What is the voltage? Say for example 210, 220 voltage, here is 110. So the ratio is 2:1. So based on the ratio, you need to draw the number of windings also. Okay, this is the single line representation. So this is how they will draw, because so any numbers, say not only 6 and 3. So here I have drawn as 2:1, no? So 6 and 3. So if you are drawing 10 and 5, very good. If you are drawing here 4 and 2, good. So based on the whatever your ratio, whatever, say for example, whatever the numbers you take, but the ratio should be 2:1. That's all. So this approximate representation of the transform. So here R1 is there. So R1 here 2.5 ohms. Here X1 is 6 ohms. So V1 is 220 volts. And here transformer works on the principle of mutual induction. And what is meant by transformer is nothing but, so transformer is a static device which converts one form of the power or energy or voltage to another form of the voltage without changing the frequency. So frequency is maintained constant in the transformer. Now R2 is what? Here R2 is 0.25 ohms, X2 is 1 ohms, and V2 is 110 volts. So it is connected to a load. So this is the approximate representation of a transformer connection. Now we need to draw the equivalent circuit of the transformer referred to as secondary. So with respect to secondary, so we need to convert all to secondary parameters. So that is secondary means 2, no? R2 like that. So R2 here with respect to R secondary means, so this parameters also R1 and X1 we need to convert it to secondary. So while conversion, you need to multiply with K square. Okay, say for example, if you are converting secondary parameters to primary means divided by K square. If you are converting this side to this side into K square, that's all difference. So rest are all same, that you know. So equivalent circuit of the transformer referred to secondary is, so first R2 I have drawn. Next, with respect to this, this is going to this side means R1 dash. So R1 dash is equal to K squared into R. So K squared is what? K is given, transformation ratio is given. That means 0.5. So 0.5 squared into R1. 2.5. So if you multiply, you'll get the R1 dash as 0.625. Similarly, X2 is there, 1 ohm is there. So now we are converting this X1 to this side. So X1 to this side means X1 dash. X1 dash is equal to K squared into X1. So K squared is what? 0.5. So K is 0.5. So 0.5 squared into X1. X1 is what? 6 ohms. So if you're converting, it will becomes 1.5 ohms. Now this side is K into V1. Okay, this is the K into V1. So K is 0.5 into V1 is 220. So if you multiply, you will get 110 volts. So this is the equivalent circuit of transform, that is primary parameter referred to second. Okay, because in the problem it is given as equivalent circuit of the transformer, draw the equivalent circuit of the transformer referred to second. So with respect to primary only, we are referring to second, so that means is the diagram of primary parameters referred to secondary. That means equivalent circuit of the transformer. Okay, so next, what we are doing is we are calculating the equivalent resistance also with referred to secondary. That means R naught 2. R naught 2 is equal to R2 plus R1 dash. That means R2. So what we are doing is we are converting this into 1. So that means R naught 2. That parameters were. So this plus this. So this plus this value 0.25 plus 0.625. Okay, so that is R naught 2 is equal to R2 plus R1 dash. So R1 dash is what? K squared into R1. So 0.25 into K squared. This already we calculated 0.5 squared into R1. That is 2 into 2.5. This we calculate as 0.625. If you add this one, 0.875. That is R naught. Next is we are calculating equivalent reactance of the transformer referred to second. That is X naught 2 is equal to X2 plus X1 dash. So X1 dash already we calculated here itself. So K squared into X1. So K squared into X1. So K squared 0.5 squared into X1 is 6. We simplify, we'll get a 1 plus 1.5, that is 2.5 ohms. Okay, that is X naught 2. So even we can calculate the equivalent impedance referred to secondary, that is magnitude alone you can calculate. That is square root of R naught 2 square plus X naught 2 square. So if you calculate this one, you'll get 2.648 ohms. Now impedance is it not to impedance. Okay, so as a whole we are calculating, that means R naught 2 plus j into X naught 2, that means 0.875 plus j into 2.5 ohms. Now equivalent circuit of the transformer referred to secondary. So what we are doing is we are converting into one. So here we have two, no, R2 and R1 dash, here X2 and X1. So this two we are converting into R naught 2, this two we are converting into X naught. That's all. So it's very simple. Just we are adding. Okay, adding and redrawing the equivalent circuit. That's all. R naught is equal to. So already we calculated, that is 0.875 ohms. X naught 2 also we calculated 2.5 ohms. So just redrawing. So here also K into V1 is equal to 110 volts. Here is load. Similarly, here is load. So here now we are we are converting this also R and X into impedance. Okay, so that is impedance Z naught 2 is equal to 0.875 plus J into 2.5 ohms. So that also we are converting and writing. So 0.875 plus J into 0.5. So this is the load. So K into V1 is equal to 110 volts. So already we calculated 110 because K is 0.5 and V1 is 220. So this here we calculated, that is 110 volts. So that's all. So this is the this is how you need to draw equivalent circuit of the transformer referred to the secondary with respect to the primary. That's all. Very simple. Easily you can score 5 marks or 10 marks or 2 marks. So whatever, suppose one part they will ask in 2 marks also, like that. Whatever is as easily you can score the